Today we will study structure of atom, the different models of atoms. Now first let us start with J.J. Thomson model of atom. Now what did J.J. Thomson say? He said that atom is a sphere of positive electricity in which electrons are embedded so as to neutralize the positive charge. So that means how many electrons are embedded? इतने electrons embedded हैं कि जितना भी positive charge है वो completely neutralize हो जाए. So that means he could explain the electrical neutrality of the atom. But what was the limitation of Thomson's model of atom? That it could not explain the results of Rutherford's scattering experiment, which was carried out later on. Now let us study Rutherford's model of atom. Now what did Rutherford do? Rutherford took a gold foil and bombarded it with alpha particles. Now alpha particles are fast moving particles, they are heavy and they are positively charged. So what did he observe? He observed that many alpha particles went undeflected straight through the foil. Now what does this mean? That if these alpha particles, they are going undeflected straight through the foil, this indicates that atom has lot of empty space. Then few alpha particles deflected back completely and very few alpha particles, they also deflected back through small angles. So what does this indicate? That atom contains a positively charged body which is heavy in the center, and this heavy positively charged body which is present in the center, this is known as the nucleus, and the entire mass of the atom is concentrated in this body. It consists of protons and neutrons. So that means mass number of an atom, how do we calculate that? That is the number of protons plus number of neutrons. And atomic number of an atom, that is equal to the number of electrons or number of protons in neutral atom equal to protons. Number of electrons equal to the number of protons. Now this is represented by A and this is represented by Z. So Rutherford said that nucleus consists of protons and neutrons, and there is a second part in the atom, that is the extranuclear part, which comprises of electrons and they are revolving around the nucleus in circular orbits, and this is known as the extranuclear part. And electrons, they do not contribute to the mass of the atom because their mass is negligible. What is the mass of electron? Mass of electron is 9.1 into 10 to the power minus 31 kg. So now what was the limitation of Rutherford's model of atom? That it could not explain the stability of atom. Now we move on to electromagnetic wave theory. What is electromagnetic wave theory? Now electromagnetic wave theory says that light from any radiation is coming continuously, and this is known as radiant energy. Then it says that these radiations have electric field and magnetic field component, and these electric field and magnetic field components, they are perpendicular to each other, and both of these are perpendicular to the direction of propagation of light. So we have electric field component, we have a magnetic field component, and both of these are perpendicular to the direction of propagation. They are perpendicular to the direction of propagation. Okay. Now these radiations, they travel with the velocity of light. What is the velocity of light? It is 3 into 10 to the power 8 meter per second, and they possess wave character, and they do not require any material medium for propagation. Now, what were the limitations of electromagnetic wave theory? The limitations were that it could not explain the photoelectric effect, and it could not explain the black body radiation. It could not explain the black body radiation and photoelectric effect. Now, we will explain this photoelectric effect after the Planck's quantum theory, because due to these limitations then came another theory given by Planck, that is Planck's quantum theory. So, now we will study the postulates of Planck's quantum theory. Now, what did this theory say? That light radiation is emitted from any source discontinuously and not continuously in the form of small packets of energy, and in case of light, each packet of energy is known as photon, and otherwise each packet of energy is known as quantum. And what it is say, that energy of each quantum is directly proportional to frequency, and when we remove this proportionality sign, we get a constant, that is h. What is h? H is Planck's constant. And what is the value of Planck's constant? It is 6.626 into 10 to the power minus 34 joule second. This is the value of Planck's constant. Now, what happens is, it says that energy of each photon is an integral multiple of h nu, always. Energy is always an integral multiple of h nu. So, where n is an integer. Now, we will understand photoelectric effect. Now, when light of certain minimum frequency, that minimum frequency is known as nu naught, that is threshold frequency, falls on the surface of a metal, electrons are emitted. This is known as photoelectric effect. Now, which type of metals can show this effect? Metals which have low ionization energy, so that the electron can easily come out of the metal, that they show photoelectric effect. So, that means alkali metals may, when we talk about potassium, we talk about cesium, they have low ionization energy. So, they are used to make photoelectric cells. We mainly basically we use cesium, because cesium has the lowest ionization energy. So, it can be used to make photoelectric cells. So, now how do we find out kinetic energy? Now, suppose my incident radiation has a frequency nu. So, this is my incident frequency and nu naught is my threshold frequency. So, when do you expect the electrons to be emitted or photoelectric effect to happen? Whenever nu is greater than nu naught, photoelectric effect will take place. So, that means जो extra energy है, now h nu will be the incident energy, and what will be h nu naught? H nu is the incident energy और h nu naught क्या होगा? It is the work function or it is the threshold energy Now, kinetic energy is equal to h nu minus h nu naught to the extra energy which you have given. Now, suppose if your incident energy is greater than the threshold energy, the extra energy will be imparted to the electron as the kinetic energy of the electron. So, the formula of kinetic energy will be h nu minus h nu naught. So, kinetic energy ko we can also write half mv square. So, if we want to find out the velocity of the emitted photoelectron, so that means velocity we can find out from here. Now, how many photoelectrons will be emitted. It will not depend upon the frequency. It will depend upon the intensity of the light. So, that means number of photoelectrons emitted depends on it is directly proportional to intensity, and when we say the velocity of the photoelectron, velocity will depend on frequency. Now we will understand the emission spectrum of hydrogen. Now emission spectrum of hydrogen, how is it obtained? Now when we take hydrogen gas in a discharge tube and we pass electrical discharge through it, what happens is that emission spectrum is obtained. We have to take it at low pressure because gases, they conduct electricity only at low pressure. So emission spectrum of hydrogen is obtained and we get different lines which fall in different regions, and so they have been grouped in different series. So let us study these series. Now what are the different series? We have Lyman series, Balmer series, Packen, Brackett and P-Fund. Now what is the region for Lyman series? It is UV, Balmer is visible, we have Packen, that is IR, infrared, and we have also Humphrey series, which is far infrared, which lies in the far infrared region. Now N1 is fixed for all these series and that is what you have to remember, but N2 value depends on the electron in which line it will fall. So it can be 2, 3, so on till infinity, 3, 4 till infinity, 4, 5 till infinity, 5, 6, 6, 7, 7, 8 and like this, so on. Now there is a formula, that is Rydberg formula, by which we can find out the wavelength, the wave number or the frequency of these lines. Now Rydberg formula is nu bar is the wave number is equal to R 1 upon N1 square minus 1 upon N2 square into Z square. Now what is nu bar? Nu bar is the wave number and we can also write it as 1 by lambda, it is reciprocal of wavelength. And what is R? R is Rydberg constant 109,677 centimeter inverse. It is also equal to 1.1 into 10 to the power 7 meter inverse. Now I will tell you how to solve a problem based on this. Now suppose my question is that you have to calculate the wavelength of wave number of shortest wavelength transition in Balmer series. Now we will apply the Rydberg formula. Shortest wavelength transition means the last line. It corresponds to the last line of any series. Now what will be the last line? For last line, that means you have to put the electron into the infinite orbit. N1 क्या होगा? N1 would be 2 because for Balmer series N1 is fixed. I told you that you have to remember N1 for all the series. And for N2, N2 will be infinity for last line because we are putting the electron in the last orbit. Now let us substitute it in the formula. Nu bar is equal to R. First we will find out the answer in terms of R and after that we can substitute the value of R. So 1 upon 2 square minus 1 upon infinity square and we are finding it for hydrogen atom. अगर हम किसी और, like if we are given lithium 2 plus, helium plus, then we can put the atomic number of that particular atom, but otherwise if it is not mentioned, we will take it for hydrogen atom, that is 1. So now 1 by infinite square, it will be 0, not defined. So my answer would be 4 by r, and then I can always substitute the value of r. Now this was the wave number for shortest wavelength transition. Now suppose I have to find out the wave number for longest wavelength transition. Now longest wavelength transition corresponds to the first line of any series. Now let me find out for longest wavelength transition in Balmer series. So it will correspond to the first line, and for Balmer series first line would be n1 equal to 2, 2n2 equal to 3. So that means when I substitute, I will get 1 by 2 square minus 1 by 3 square into z square, that is 1. So my answer would be, this is 1, so it would be 5r by 36 on substituting the values. And if I have to find out wavelength, my answer would be 36 by 5r. After Rutherford's model, because I told you that Rutherford model was not able to explain the stability of the atom. So next model was Bohr's model of atom. Now what did Bohr's model of atom say? Bohr again, he said that atom consists of a heavy positively charged body, that is nucleus in the center, and electrons are revolving around it in circular orbits. Then the entire mass of atom is concentrated within the nucleus, and the charge of the nucleus is due to the presence of protons. We say that nucleus is positively charged, so it is because of the protons. Now then what did Bohr say? He said that energy of an electron in an orbit is quantized. What do we mean by quantized? That the energy is fixed. Energy of the electron is fixed. Now we call these orbits as stationary states. Now what does the word stationary means? Stationary means fixed. Now this does not mean that the electron is fixed, or the electron when it is in a particular orbit it is not moving. The word stationary means that the energy of an electron in a particular orbit is fixed. So what do we mean by that? That energy is quantized. Fixed means that it is quantized. Or when will the energy change? When the electron will jump from one orbit to the other orbit. Then only if it absorbs energy, it will move to the higher energy level, and in case it emits energy, it will come back to the lower energy level. So that means energy will change only when electron will move from one orbit to another, and till the time it is in a particular orbit, it is fixed. Now there is a formula by which we can find out the energy: 2 pi square me4 upon n square h square, and this energy is always negative. Electronic energy is always negative. Mass, we all know mass of electron. We know the charge on electron, minus 1.6 into 10 raised to the power minus 19 coulombs. We know the value of Planck's constant, h also. So when we substitute all these fixed value, I am left with the formula. In different units I will get the formula. So suppose I want to get it in electron volt per atom, this would be my formula. If I want to get it in kilojoule per mole, my formula would be this. So I can substitute any formula which I want. This is kilojoule per mole. Suppose I want to find out the energy of an electron when it moves from orbit number 5 to orbit number 3. So what will I do? Delta E would be E5 minus E3. final minus initial. I will get the value. So, I will just substitute these formulas, I will put the value of n and I will get it. Now, suppose I want to find out the ionization energy of hydrogen atom. Now, what do I mean by ionization energy? Ionization energy means energy required to completely remove an electron from the orbit. Now, if I am removing the electron completely, what does that mean? It means that I have to take this electron to the infinite orbit. I have to put it in the infinite orbit. So, ionization energy of hydrogen, if I have to find out, it would be E infinity minus E1. Now, energy of an electron in infinite orbit is 0. So, I will take it as 0. Then I will calculate the energy in the first orbit. I will put the formula minus 1312 by 1 square into n square, that is also 1. My answer would be plus 1312 kilojoule per mole. Now, why here I am getting a positive charge? Because ionization energy is the energy which you have to give, which you have to supply, it is not the energy which is released. So, answer has to be positive. So, this is the ionization energy for hydrogen atom. Now, suppose I want to find out ionization energy for any other hydrogen like particle. Now, what do I mean by hydrogen like particle? Now, hydrogen has one electron. So, all the species which have one electron, they are known as hydrogen like particles like helium plus, lithium 2 plus, beryllium 3 plus, they all have one electron, but what is different in them? Their atomic number is different. So, formula which I have to use is this, but here I will substitute the orbit number and here I will substitute the atomic number of these particular species. Now, if I have to find out ionization energy of lithium 2 plus, what will I do? My formula will become ionization energy of hydrogen into Z square. So, I just will have to substitute 3 square into ionization energy of hydrogen, that is 1312 into 9 kilojoule per mole would be my answer. Now, if the question says that you have to completely ionize an electron from the 5th orbit, if it is mentioned that you have to ionize it from the 5th orbit, then what will you do is delta E would be final minus initial, क्योंकि the electron now was in 5th orbit. But if it is written that you have to only calculate the ionization energy, then what you will do is you will take the ground state, that is you will take N1 equal to 1. तो आप समझ जाओगे that you have to remove the electron from the first orbit and you have to send it to the infinite orbit. Now, if you have to find out the radius of orbit, so again we have a formula for radius of orbit. Radius of orbit Rn is equal to A naught into n square by z. Now, what is n? N is the number of orbit and z is the atomic number and A naught is the Bohr radius. What is Bohr radius? It is the radius of first orbit, that is 52.9 picometer or it is 0.529 angstrom. So, whatever units you want to substitute, you can substitute. Now, if we want to find out the velocity of an electron in a particular orbit, again we have another formula and the formula is Vn is equal to V naught into Z upon n. Again, what is V naught? V naught, the value is fixed, it is the velocity of electron in the first orbit. So, whatever you have to find out, you will substitute the value of Z, you will substitute the value of n and you will find out the answer. Now, I told you that energy of an electron is quantized. Like energy angular momentum of an electron is also quantized, that is it has a fixed value, and we have the expression mvr is equal to nh by 2 pi, where mvr is the angular momentum. And how is it fixed? It is always an integral multiple of h by 2 pi, because n key value will keep on changing depending upon the orbit in which electron is present. Now suppose I say I want to find out the angular momentum of an electron in third orbit. I am saying I have to find out the angular momentum of an electron in third orbit. My answer would be 3h by 2 pi. In fourth orbit, 4h by 2 pi. So that means it is always an integral multiple of h by 2 pi. So what do I mean? That like energy, angular momentum of an electron in a particular orbit is also quantized. Now, what was the limitation of Bohr's model of atom? It could not explain the three-dimensional model of atom, then it could not explain the Heisenberg uncertainty principle, it could not explain the de Broglie relationship, and it could not explain the spectrum of multi-electron atoms in which more than one electron is present. Now we will understand the concept of de Broglie relationship and Heisenberg uncertainty principle. Now we will understand the de Broglie relationship. Now what did de Broglie say? De Broglie said that like light has dual nature, that is it has wave character as well as particle character, like this every material particle has dual nature, that is we all have wave character as well as particle character. Now he gave a relationship, that is lambda is equal to h upon p. Lambda we know it is wavelength, h we know it is Planck's constant. What is p? P is the momentum. And what is h? H is the Planck's constant. Momentum is a product of mass into velocity. So my equation will become h upon mv for any other material particle, any material particle, and it will become mc for light, because if the particle is moving with velocity of light, we have to substitute c. Now what is the significance of de Broglie equation? Now we all can see here that lambda is inversely proportional to mass. So that means that lambda is significant only for microscopic particles here. Kyunki now we all have wave character, if I am moving there would be a wave, but why you cannot see that wave? Because wavelength is inversely proportional to mass. So if the mass is large, wavelength would be very small. So that means this de Broglie relationship is applicable only to microscopic particles, and that is why we can see the wavelength of subatomic particles and not of the large bodies. Now if you have to find out that if an electron is moving in a particular orbit, then how many waves will it generate? Now one thing that you have to remember is that I am calculating number of waves in fourth orbit. Number of waves in fourth orbit generated by an electron. Now what will I say? That 2 pi r is equal to n lambda. What does this mean? That circumference of the orbit in which the electron is moving is equal to, is an integral multiple of the wavelength with which the electron is moving. So that means number of waves क्या हो गए? If I have to find out the number of waves, my formula is 2 pi r by lambda is equal to n. Now by de Broglie relationship we know that lambda is equal to h by mv. So I substitute it here and I rearrange now mvr. If I see here, अभी मैंने आपको बताया था what is mvr, it is angular momentum, and what is the value of angular momentum? It is an integral multiple of h by pi, h by 2 pi. So that means here I can also write nh by 2 pi instead of mvr. This, what is this? This is Bohr's postulate of angular momentum. Now what is this n here? I can cancel this. ये वाला n क्या है? This n here is number of orbit. And what n is this? This is number of waves. So what do I get? That number of orbit is equal to number of waves. That means if an electron is moving in 4th orbit, it will make 4 waves. If it is moving in 5th orbit, it will make 5 waves. So this is number of orbit is equal to number of waves. I have proved this. Heisenberg uncertainty principle. Now what is the statement of this principle? It says that it is impossible to measure simultaneously the position and momentum of an electron or a particle with absolute accuracy, and if we try to do the same, if we try to measure one of these quantities accurately, the other becomes uncertain. How do I express that mathematically? I will say that delta x into delta p is nearly equal to h by 4 pi. What is delta x? Delta x is uncertainty in position. What is delta p? Delta p is uncertainty in momentum. Now I told you that momentum is a product of mass into velocity. Now since mass cannot be uncertain but velocity can be uncertain, so what can I do is I can substitute delta p equal to, I can write m delta v. I can write it as m delta v. So when I substitute it in the formula becomes this, right? So now using this Heisenberg uncertainty principle, I have to show that why electron cannot exist inside the nucleus and why it is only revolving outside the nucleus. Now we are showing why electron cannot exist inside the nucleus. Now what is the atomic diameter? It is 10 to the power minus 15 meter, and if atomic diameter is 10 to the power minus 15 meter, what does that mean? It means that uncertainty in the position of electron can only be this. So now let me substitute the values. Delta V I will find out from here, h by 4 pi m into delta x. I will substitute the values here. All values I know, 3.14 into 9.1 into 10 to the power minus 31, and I also know this. So when I find out delta V from here, delta V comes out to be 5.77 into 10 to the power 10 meter per second. Now this is much higher than velocity of light. So what does this mean? This means that electron cannot exist inside the nucleus. Now we have covered all the concepts here. I have told you how to apply the formulas. You are given certain questions in the module which are related to all these concepts. So you will apply all these concepts and you will find that you would be able to solve all the numericals and do all the questions. Thank you. God bless you.